So I'm delighted to be here as a part of the panel on affective computing alongside my colleagues. This particular panel follows up on a special issue that was on the same topic that was published in the Proceedings of the IEEE last year. My specific focus is going to be on human speech in this context. So my name is Narayanan. I'm from the University of Southern California. I'm going to be representing this work of my colleagues, Professor Jeremy Lee, Theodore Chaspari, and Emily Maurer, Provost. So before we start, I thought maybe we'll just have a level setting of what we mean by affective computing. Basically, we can think about this as a computational study of human affect and the design and development of technologies that help analyze, process, and simulate human affect. So it's inspired by a lot of different applications we'll touch upon in this webinar today, and mine will focus on human speech. And so why human speech? So when we think about human speech communication, right, the human speech, like the one I'm producing right now, is a very special biosignal. It is produced by people, for people, and it is very information rich. There's an encoding process, the way we plan our thoughts and ideas and feelings into a message and a signal that we share, we produce using the acoustic waveform, but also accompanying other signals like visual gestures of the hand and the face and so on. And it is often targeted toward one or more people, right? It is again decoded by the receiver, and they process the information that we convey and respond back. And this very intricate and sophisticated chain of production and processing involves various systems in the human, right? From the neurocognitive processes to the physical mechanisms of producing the signal to sociocultural context in which these occur. So as a result, it's a very fascinating signal. It carries, communicative messages, encodes intent, emotions, mood, but also encompasses things like personal traits and physical and psychological states, including health status. It reflects where we are, right? Are we in a quiet room or in a noisy space? Are we in an office context? So all these things influence the nature of the signal. So hence, it's a very special signal. Computing with speech signal, right? Hence, for decades has been fascinated about various aspects of this multifaceted signal, including decoding the content, generating speech, recognizing various attributes that this particular signal carries, including analyzing affect information that's encoded in this signal. So the paper that my colleagues, Professor Chichun, Jeremy Lee, Theodore Chaspari, Emily Maurer, Provost, myself, contributed to the special issue, focused on an engineering view of emotions and speech from analysis and modeling to actually developing responsible human-centered applications. As we know, with this resurgence of AI and AI applications especially, there are numerous technological possibilities that have emerged and that are emerging, and of which, right, truly to be able to connect with people, we need to know go beyond transactional aspects of an interaction to know who we are interacting with, how people are interacting with, and knowing the aspects of affect that's encoded and also conveyed to them in a responsible way. So since we said this is a biosignal, right, there's a lot of science behind the generation, processing, and use of the signal by people, right? So a lot of aspects of this computing computational approaches focus on how we can understand these mechanisms better, from the brain and the body to actually the sociocultural aspects. The other aspects focus on how we process this, analyze the information encoding, how does it happen, how can we bring to bear and develop new machine learning and other computational methodologies to analyze this signal, and then how that it can inform diverse applications in the real world, right? And one important aspect, which I'll touch upon in this particular remarks, is the notion of trustworthiness of these technologies, right? How can we make sure that something that is very close to people, that reflects, a signal from people for people, also respects aspects of that trustworthiness and be trusted in terms of privacy and security, equity and inclusion, and the broad aspects of ethics. And this is something that my colleagues and I strongly believe in and have conveyed in this particular paper. So one often way, like a simple way of when we think about analysis with speech, or in general affective computing, typically a pipeline looks like, this is not necessarily all inclusive, but in general, where it started and is to have a particular perspective of this affect that is expressed by an individual as perceived or processed by a third person or observer, usually captured in terms of a labeling or annotation process. We are very familiar with it across various machine learning applications. And then speech data can be gathered, through a number of different diverse devices, from a microphone on a computer or a mobile device to various other IoT possibilities. And then the idea is to learn the mapping between these perceived labels of emotions and a lot of different theoretically and empirically inspired representations that people have proposed and work on. And then the idea is to learn these maps, and these maps can be learned with now contemporary neural architectures of various sorts. A lot of this is in fact geared toward many applications where these insights can drive a better human experience. So that's the general pipeline and idea of this human. So diverse applications abound, right? From healthcare to customer service to, in advertisement, retail. A lot of different applications are there by using affective aspects of that's available in the speech signal, right? In fact, there are many different predictions about the market potential, that it is going to be a several billion-dollar industry. So, many startups in the AI world have been focused on this and are thriving in this area. So it's also a commercially sort of exciting domain to be in, right? With that, right? There are two, we have to stop and think about two different aspects. There's two, specific views. On the one side, right, there are, since I alluded to earlier, this is a signal that is very close to people, but also probes the hidden states of, affective states that can be, short-term emotions or long-term moods or feelings or other aspects of affective cognitive constructs. And question is, it raises a lot of issues, concerns, and doubts in a very and it's very reasonable to think about those, right, of these risks, right, in interpreting and using, thinking about human emotions from a third-person perspective, for example, right? And so these are abound, right? As a result, this is not just true for affective computing, but the general broad area of AI. As a result, there's the broad global AI policy landscape. They try to say consider these and address these, and how do we ensure safe, secure, and trustworthy AI across the world? This has been encoded or codified in terms of various policies and regulatory activity across the world, right? So this is one of the backdrops we have to clearly, understand and base much of the work we are trying to do, imagine, and so on, the impact it can have, both unintended and even if it's unintended on the humanity and society, right? In fact, I'll just highlight a couple of those, especially that were relevant and recent, right? One that requires this red teaming, that is the need for performing safety tests on all these AI technologies, including affective computing, and the EU regulation that has laid out the risks involved, the various levels of risks involved in the use of human-centered AI and AI tools across various domains. For example, inferring emotions in workplaces and educational institutions are prohibited by this, except for medical or safety reasons, as they say. So a lot of things are happening, and this is a very dynamic area, right? But on the other side of this coin, right, acknowledging these concerns, and there are a lot of opportunities and usefulness and enabling human-centered applications across societal domain. Especially, I would like to underscore the role of these kinds of affective computing technologies, including from an easily acquirable signal like speech and spoken language, in service of healthcare, for example, patient care, understanding a person's health status, and supporting providing additional enhanced communication abilities, and so on, right? So there's both challenges, but also a lot of possibilities. And the question for researchers and technologists and entrepreneurs is to think about how to seek a good balance. So one way of doing this, as a community people are evolving, is to think about intentionally the various aspects of trustworthy AI within which affective computing resides, right? Safety. Is the technology going to be safe? Would it ensure privacy and confidentiality as desired by the users of this technology? Are these technologies fair and inclusive? Does it work well across, regardless of who you are and where you are, right? These are elements. I'm just going to the next few slides, quickly give a couple of examples of this. Privacy preservation, why do we care about, right? Many of these elements that are associated, available in the speech signal, right? How you are communicating, who you are, what are you saying, are all like very intertwined. So for example, the leaking of speaker identity and other demographic indexable information, in the emotion representation or embeddings has been established by many researchers. So what do you do with it, right? So there are people now thinking about how do you defend against these, how do you preserve privacy by appropriately only making available the information of interest for that particular context, and trying to suppress or eliminate other forms of information. For example, in this this exemplary work that is on the slide, we have tried to show how we can suppress information about a person's perceived gender while only releasing information about the perceived affect state, right? Likewise, another big element of trustworthiness is the technology being inclusive. As you know, inherently, some of the signal, for example, the acoustic speech signal, shows significant differences in the information it encodes due to biological or non-biological reasons. For example, in this work led by Professor Chaspari's lab, they showed that there are significant differences across these various indexical characteristics, gender and race and so on, in the speech signal, right? So this is in properties like the vocal, like fundamental frequency, the shimmer in the F0, and so on. So what do you do with it? Well, we can try to see how we can make use of these kinds of knowledge that we know about the biological and the scientific basis of the speech signal, in trying to understand provide explainable representations, and then selectively deal with it. For example, we know different vocalic patterns have different encoding of affect information. So can we use that in providing different explainable aspects in the learning algorithms we develop with these machine learning tools, right? In this work, they've showed that by associating the vocalic information, phoneme-specific information as a process, we can provide better explainability of the model in some downstream tasks, like measures of depression and so on, right? This can happen also at the higher level between the tools, affective computing aware or sensitive AI tools, and the humans that use, in collaborative way, so thinking about humans and AIs as teams, and how that can help develop better AI, explainable AI systems. So these are various trends that are happening, both in acknowledging and highlighting some of the challenges associated with it, both scientific and socio-technical, and how we can develop both methodologies and approaches to address these. So final slide. To conclude, the perspective of the affective speech research is that computational approaches in affective computing provide enormous possibilities to analyze and understand the very fundamental nature of this important aspect of how we encode, use, and process and interact with affective elements in our communication. We can develop technologies to enhance these human experiences. But while doing this, we have to be very mindful about the individual and societal impact, and every use case and everything has to be carefully considered, in light of all these challenges that we just mentioned. So, thank you.